Something is making noise in the deepest part of the ocean. Not the groaning of tectonic plates, not the click of shrimp. Something biological, something massive. And the scientists who recorded it still cannot tell you what it was. The Bloop. In the summer of 1997, NOAA's Autonomous Hydrophone Array, a network of underwater microphones originally built to track Soviet submarines, picked up a signal in the South Pacific that immediately stopped everyone in the room. The sound was loud enough to be detected by sensors nearly 5,000 kilometers apart. That is not a typo. Whatever produced it was powerful enough to travel across an ocean basin and still register clearly on the other side. Scientists named it the Bloop because of its rising blooping quality, and they ran it back through every database they had. It matched nothing. No known geological event, no identified marine species, no mechanical source. What made the Bloop genuinely alarming was a single fact that kept surfacing in every analysis. The acoustic profile was biological. The way the sound was shaped, the way it rose and modulated, matched the signature of a living organism producing noise intentionally, not a passive geological release. The blue whale is the loudest animal on Earth. The Bloop, at its detected amplitude, would have required an organism many times larger than a blue whale to produce it. NOAA eventually settled on icequake activity as the most likely explanation. The fracturing of Antarctic ice shelves generating sounds with an oddly biological profile. Most scientists accepted that. But the original analysts never fully ruled out the biological hypothesis. And in 2005, the array picked up something new, the Julia sound. On March 1st, 1999, NOAA's hydrophone network recorded another anomalous signal, this one lasting 15 seconds and audible when sped up to human hearing range. They called it Julia because it sounded uncomfortably like someone moaning. The signal came from the South Atlantic near the equator, and unlike the Bloop, it did not fit the icequake profile at all. The source was traced to a region near the East Pacific Rise, but the direction kept shifting during analysis, which meant the sound was either moving or bouncing off underwater terrain in ways that defied easy modeling. What made Julia disturbing to the analyst who first reviewed it was the duration and the consistency. Geological events tend to produce chaotic, irregular acoustic patterns. Julia held a steady, modulated quality across its entire length. Biological sounds, by contrast, have exactly that kind of structure. They are produced by controlled anatomical mechanisms. When NOAA published Julia, in their unexplained sounds database, they listed the cause as possibly an iceberg that had run aground. But the signal has never been conclusively matched to a verified geological event. It sits in the database today, next to the Bloop and a handful of other sounds that nobody has been able to explain away completely. And then there is the sound that was never explained at all, the slow down. Recorded on May 19, 1997, less than 2 months before the Bloop, the slowdown was detected by the Eastern Equatorial Pacific Hydrophone Array and named for its most obvious quality. The sound slowly decreased in frequency over roughly 7 minutes, dropping steadily like something winding down. Its origin was triangulated to a point near Antarctic coastline. NOAA's initial analysis flagged it as potentially consistent with the movement of ice, but the geographic triangulation kept producing a location in open ocean, far from any confirmed ice structure. Slow down remains in NOAA's official unexplained sounds catalog. What is striking about it is the duration. 7 minutes of controlled, slowly descending frequency. That is not how rock breaks. That is not how ice fractures. That is how a very large animal might modulate a call as it dives, dropping in pitch as it descends through pressure gradients. No one has proved that, but no one has disproved it either. The sound was real. The source was not definitively identified, and it was recorded in one of the most poorly mapped ocean regions on the planet. The train. This one is harder to explain away. In 1997, the same year as the Bloop and Slow Down, NOAA's network captured a signal. They named train because of its rhythmic, repetitive quality, a steady pulsing that sounded almost mechanical, but carried the variable modulation that signals a non-mechanical source. Train was detected across multiple hydrophone arrays simultaneously, allowing a more precise triangulation than most anomalous sounds. The source traced to the East Pacific. The signal repeated with a regularity that was almost unsettling, not exactly like machinery, but not like anything in the biological database either. One researcher who reviewed it described the experience in a public lecture years later. She said that after the first few seconds, the room went quiet. Not because it was loud, because nobody could think of anything to say. What you hear when you slow down and filter the recording is a pulse, followed by a gap, followed by a pulse, at intervals that are consistent but not perfectly mechanical. Living things are like that. Heartbeats are consistent but not metronomic. Whale calls repeat but vary slightly. Train sits at that exact ambiguous line. NOAA listed it as unexplained. It remains that way. The upsweep. This is the one that should concern you most, because it did not happen once. The upsweep is a signal that NOAA's hydrophone array has been recording seasonally since 1991, when the network first became operational. It happens every year, every spring and autumn, a narrowband signal consisting of a long series of upsweeping tones. Each one, rising in pitch, appears in the Pacific. The source has been triangulated repeatedly to a region near active undersea volcanic areas around 54 degrees south. The volcanic explanation has been offered and debated. But here is the problem. Volcanic sounds do not have seasonal patterns. Rock does not follow the calendar. Biological organisms do. Seasonal acoustic behavior, calling in spring, calling in autumn, is a fundamental feature of animals. Mating seasons, migration patterns, feeding aggregations. The upsweep's seasonal regularity is the single most biologically consistent feature of any unexplained deep-sea sound on record. And it has been recorded continuously for over 30 years. Scientists have proposed that the volcanic hypothesis is sufficient. Many have accepted it. But the seasonal timing has never been satisfactorily explained by any geological model. Something in the deep South Pacific has been making the same sound every spring and autumn for at least 3 decades. We do not know what it is, the 52 hertz whale. This one has a name, and the name is wrong, and the wrongness of it is what makes it so haunting. Since 1989, NOAA's hydrophone network has tracked a whale-like signal traveling through the North Pacific at a frequency of 52 hertz. All known baleen whales communicate between 10 and 40 hertz. Blue whales call at around 10 to 20 hertz. Fin whales at 20 hertz. The 52 hertz signal is too high for any known species. It follows the migration patterns of a large baleen whale, moving north in summer, south in winter, traveling thousands of kilometers each year, maintaining the pattern across decades. It is almost certainly biological. It is almost certainly a whale of some kind. But 52 hertz means that if it is a known species, no other member of that species can hear it. They call at different frequencies. The 52 hertz whale has been calling into the void for at least 35 years, and nothing has called back. Marine biologists have proposed it is a hybrid of 2 species, or a malformed individual with an anatomical abnormality affecting its call frequency, or a completely unknown species. The hybrid hypothesis is the most scientifically accepted. But the whale has never been visually confirmed. Nobody has ever seen it. It has been tracked by sound alone across 3.5 decades of migration, and it remains unidentified. And this is the detail that the scientific papers tend to understate. If it is a new species, it would be the largest undiscovered animal alive, something the size of a blue whale that nobody has ever photographed. The Mariana Trench Bioduct. The Mariana Trench is the deepest place on Earth, reaching 10,935 meters at its lowest point. Humans have visited it fewer times than we have visited the moon. In the 1960s and 1970s, U.S. Navy hydrophones operating in the Pacific began picking up a repetitive, short, downswept sound that analysts eventually called the bioduck because it genuinely sounds like a duck quacking underwater. For decades, it was recorded and filed away. In 2013, researchers in Antarctica finally identified the bioduck as a call produced by Antarctic minke whales. Case closed, mystery solved. But here is where it gets worse. When researchers went back through Pacific recordings to confirm the identification, they found bioduck signals in locations where Antarctic minke whales do not exist and have never been documented, including in deep water near the Mariana Trench itself. The signals in those locations remain unattributed. The sound that was solved turned out to have a doppelganger coming from somewhere else entirely. Nobody has filed that version away as solved. It sits in the database. Nobody talks about it as much as the original, the East Pacific Rise hum. For most of the 20th century, oceanographers assumed the deep ocean was mostly silent outside of geological events and whale calls. Then, in 1991, scientists deployed a seafloor seismometer network along the East Pacific Rise, a vast underwater mountain chain running the length of the Pacific floor. What the instruments picked up in addition to geological data was a persistent low-frequency hum that seemed to originate not from the rock, but from the water column above it. The hum was consistent, not episodic. It was present regardless of volcanic activity. It was present in biological dead zones around hydrothermal vents. It had no identified source. Researchers at the Scripps Institution of Oceanography spent years analyzing it, and Infrastructure proposed that it was generated by infragravity waves, extremely long-period ocean waves interacting with the seafloor. That explanation is accepted by most of the field. But a 2019 paper in Geophysical Research Letters noted anomalous variations in the hum that the wave hypothesis did not predict. The hum changed in ways that correlated with biological seasonal cycles in the overlying water column, not with wave activity patterns. Whether the connection is causal or coincidental remains unresolved. The deep ocean floor is making a noise that changes with the seasons, and we are not certain why. The darker side of what we know. Here is the thing that the Unexplained Sounds database actually tells us, and it is not about monsters. It is about scale. The hydrophone network that detected the bloop and the slow down and the upsweep covers a fraction of the ocean floor. The deep sea is not a flat basin. Is a three-dimensional environment larger than all continental land masses combined, with mountain ranges taller than Everest and trenches deep enough to swallow entire island chains. Sound travels differently in deep water. It channels, it bounces. It travels thousands of kilometers without losing amplitude. A signal recorded in the South Pacific might originate on the other side of an oceanic ridge. What we have mapped acoustically is a thin and biased sample. Every unexplained sound in NOAA's database was captured by an array designed to track submarines, not biological organisms. It was not optimized for the frequency ranges of many marine species. It was not designed to triangulate sources in 3 dimensions across complex underwater terrain. It was pointed at the wrong targets for the wrong reasons, and still managed to capture sounds nobody can explain. In 2021, a team at Oregon State University deployed a dedicated deep ocean acoustic array near the Mariana Trench with equipment designed specifically for biological sound detection. In the first 6 months of operation, it detected over 40 distinct biological sound signatures that matched nothing in any existing species database. The paper announcing this was published quietly. It has not received significant mainstream coverage. 40 unidentified biological acoustic signatures from the deepest ocean on Earth, recorded in 6 months by a single array covering a tiny area. The bloop may have been ice. Julia may have been geological. The slowdown may have a mundane explanation that nobody has found yet. But the 52 hertz whale is still out there, calling. The upsweep is still happening every spring and autumn. And somewhere in the 80% of the ocean, something we have never directly observed, something was almost certainly making sounds that no one has ever recorded at all.